Good afternoon, students. I am Arwinderjit, lecturer in production engineering from Government Polytechnic College, Amritsar. And the topic given to me today is press working operations. So, first of all, let me tell you what is meant by press working operation. Press working may be defined as chipless manufacturing process by which various components are made from sheet metal. This process is also termed as cold stamping because these type of operations are done under room temperature. That's why this process is also called cold stamping. And the machine used for the press working is called a press. The main features of a press are a frame which supports a ram or slide and a bed, a source of mechanism for operating the ram in line with and normal to the bed. The ram is equipped with punch or punches and a die block is attached to the bed. A stamping is produced by the downward stroke of the ram when the punch moves towards and into the die block. The punch and die block assembly is known as die set. The press working operation are usually done at room temperature. That's why these type of operations are called cold stamping. So, press working operations are chipless manufacturing operation in which metal is cut but there is no formation of chips, and these operations are done on a machine which is called a press. And I have already explained you, press has a frame which supports the bed and the ram or slide. Punch is attached to the ram and a die is mounted on the bed. Now, press operations. The sheet metal operations done on a press may be grouped into two categories. First category is cutting operation and second forming operation. In cutting operation, the workpiece is stressed beyond its ultimate strength. The stresses caused in the metal by the applied forces will be shearing stresses. In forming operations, the stresses are below the ultimate strength of the metal. In this operation, there is no cutting of metal, but only the contour of the workpiece is changed to get the desired product. So, in cutting operation, metal, the workpiece is stressed beyond its ultimate strength, and in forming operation, the metal is stressed below its ultimate strength. And the cutting operations are listed below. First is blanking, punching, notching, perforating, trimming, shaving, slitting, lancing, etc. And the forming operations include bending, drawing, redrawing, squeezing, etc. The stresses induced in the metal during bending and drawing are tensile and compressive, and during squeezing operation these are compressive in nature. Now, we will discuss uh, all these operations in detail. First of all, uh, what is blanking? So, as I have already told you, blanking is a cutting operation. It is a operation of cutting a flat shape from a sheet metal. The article punched out is called blank and the required product of the operation, the hole and the metal left behind, is discarded as waste. It is usually the first step of series of operations. Now, you can see on the monitor a rectangular sheet, a black rectangular sheet in which hole has been produced by taking out some portion out of it. So, this cut out piece is called a blank because this is the required product, and the hole along with the material left behind is discarded as waste. So, in this operation of blanking, the cut out piece is of a requirement and the metal left behind is waste for us. So, when the cut out piece is a requirement, then this type of operation is called blanking operation. Then comes punching. It is a cutting operation by which various shaped holes are made in the sheet metal. Punching is similar to the blanking, except that in punching the hole is the desired product, the material punched out to form the hole being waste. So, now you can see on your monitor, again we have a rectangular strip or sheet in which some material has been cut and it has been taken out. Now, in this case, this hole is our requirement and the cut out piece is discarded as waste. So, all those operations in which holes of different shapes and sizes are made and the cut out piece is waste, then this type of operation is called punching operation. Then comes notching operation. It is also a cutting operation by which metal pieces are cut from the edge of the sheet, strip or blank. Now, you can see on the monitor that some pieces are cut from the edges of the sheet. Some material has been cut from this side and some material has been cut on this side. Similarly, some material has been cut from on this edge. This type of operation in which material is cut from the edges of the sheet or strip, these operations are called notching operations. Then comes perforating. This is process by which multiple holes which are very small and close together are cut in flat work materials. You can see on the monitor very small holes which are large in number and small in size are cut. Such type of cutting operations are called perforatings. Then comes trimming operation. This is the process of cutting unwanted excess material from the periphery of the previously formed component. Now you can see a dark portion is our requirement and a portion shown with a line is excess material, and that material has to be removed. So, the process by which this excess unwanted material is removed, that operation is called trimming operation, and this is also done on a press. Then comes shaving operation. The edges of a blanked part are generally rough, uneven and unsquare. Accurate dimensions of the part are obtained by removing a thin strip of metal along the edges. This process is termed as shaving. Now you can see a rectangular workpiece which is shown by a dark black color, and some extra material is shown with the light shading. Now this material is to be removed, and the operation used for removing this uh, thin layer of sheet is called a shaving operation. Then comes lancing operation. This is a cutting operation in which a hole is partially cut and then one side is bent down to form a sort of tab or lever. Since no material is actually removed, there will be no scrap. Now you can see on your monitor a punch is cutting a strip. When the punch comes down, cutting takes place at this edge, that is at the leading edge, and no material is cut on the rear edge, and the cut portion of the hole which is partially cut is bent down to form a sort of lever. Then such type of operation is called a lancing operation. Then comes bending. In this operation, the material in the form of a flat sheet or strip is uniformly strained around a linear axis which lies in the neutral plane and perpendicular to the lengthwise direction of the sheet or material. And in simple words, a flat shape is converted into a curved shape. Now you can see this straight sheet has been bent on some angle. Now tensile stresses occur on the outer side and compressive stresses occur on the inside surface, and this dotted line shows the neutral axis. Neutral axis is an axis on which there is no stress and no strain. Due to the tension and compression, this neutral axis moves toward the inner side of the bend. Generally, this neutral axis is in the center of the sheet, but after bending operation, this neutral axis moves toward the inner side, and the distance generally noted is from 0.3 t to 0.5 t. Then comes drawing. This is an operation of forming a flat workpiece into a hollow shape by means of punch, which causes the blank to flow into a die cavity. So in this drawing operation, the material is drawn with the help of a punch into the die cavity with the help of a punch, and here no material is removed, only shape of the workpiece is changed. Then comes squeezing. Under this operation, the metal is caused to flow to all portions of a die cavity under the action of the compressive forces. Now, types of dies. Again, dies may be classified according to the type of press operation and according to the method of operation. So, if we classify the dies according to type of press operation, then dies are of two types, cutting dies and forming dies. Cutting dies, these dies are used to cut the metal. As the name suggests, these dies are used to cut the metal. So, these dies are used to cut the metal. They utilize the cutting or shearing action. The common cutting dies are blanking dies, punching dies, perforating dies, notching dies, trimming dies, shaving dies, etc. And forming dies, these dies change the appearance of the blank without removing any stock, and these dies include bending dies, drawing dies, squeezing dies. So, the point to be noted is, in case of cutting dies, the material is cut actually and the workpiece is stressed beyond its ultimate strength, and in case of forming dies, no material is cut, only contour or shape of the material is changed to some desired shape, and the material is stressed below its ultimate strength. And the classification according to method of operation, according to this criteria, the dies may be classified as single operation die, compound die, combination die, progressive die, transfer die, multiple dies, etc. Now, we explain one by one. First of all, we take single operation dies. Single operation die is also called simple dies. A simple or single operation dies perform single operation for each stroke of the press slide. The operation may be any of the operation listed under cutting or forming operation. So, in case of simple die, during downward stroke of the ram, only one operation is performed. That operation may be cutting operation or it may be a forming operation. The point to be noted is, during the downward stroke only one operation is performed, and in case of compound dies, in these dies two or more operations may be performed at one station. Such dies are considered as cutting tools since only cutting operations are carried out. Now, in compound dies, during the downward stroke of the punch, more than one operations are performed, but these operations are cutting operations. That is why compound dies are called cutting dies. Figure shows a compound die in which a washer is made by one stroke of the press. The washer is produced by a simultaneous blanking and piercing operation. Accurate and economical in mass production as compared to single operation dies. Now, you can see on the monitor a simple sketch of a compound die. Here we have this blanking punch. Correspondingly, we have a blanking die. These are the cutting edges of a blanking punch, and these are the cutting edges of a blanking die. This blanking die cuts a blank, this blank, and the hole which is produced is cut by the inverted punch which is mounted on the bed, and a die which is formed in the blanking punch. Blanking die cavity is produced on the bottom of the blanking punch. You can see it on the monitor. When this punch moves downward, this sheet or strip is cut on this sides. We get a washer like this, and the internal hole is cut with the help of this punch, inverted punch, and a die cavity which is cut on the bottom side of the blanking punch. Then comes a combination die. In this die, more than one operations may be performed at one station. It differs compound die, as in this die a cutting operation is combined with a bending or a drawing operation. Now, again with the downward stroke of the punch, we perform more than one operations, but in this combination die a cutting operation is combined with the forming operation. That is why it is called a combination die, mean combination of two operations. One is cutting operation and second is forming operation. Figure shows the working of a combination blank and draw die. The die ring which is mounted on the die shoe is counterbored at the bottom to allow the flange of a pad to travel up and down. This pad is held flush with the face of the die by a spring. A drawing punch of required shape is drawn to the die shoe. The blanking punch is secured to the punch holder. A knockout extending through the center opening and through the punch stem ejects the part on the upward upstroke as it comes in contact with the knockout bar on the press. In operation, the blank holding ring descends as the part is blanked. Then drawing punch contacts and forces the blank into the drawing die which is made in the blanking punch. Now, you can see we have two type of operation which are being performed here. One is cutting operation and second is forming operation. Cutting operation is done with the help of this blanking punch. These are the cutting edges and this is the blanking die. These are the cutting edges. Secondly, this sheet is formed into a cup with the help of a drawing punch which is again mounted on the bed of the press, and same shape is maintained on the bottom side of the blanking punch. So, after cutting this blank, these portion of the blanks are held with the help of a die ring and stripper. Then this portion is drawn into the drawing die, and after the end of the operation we get a cup shaped form. Then comes a progressive die. A progressive die has a series of stations. At each station an operation is performed on a workpiece during a stroke of the press. Between strokes, the piece in the metal strip is transferred to the next station. A finished work is made at each stroke of the press. A progressive die is shown in the figure. While the piercing punch cuts a hole in the stock, the blanking punch blanks out a portion of the metal in which a hole had been pierced at a previous station. Thus, after the first stroke, when only a hole will be punched, each stroke of the press produces a finished washer. Now, you can see on the monitor a simple sketch of a progressive die in which with each stroke of the ram, two holes are cut. One is piercing hole, one is hole, and second is for producing a blank for the washer in which a hole has already been cut. First of all, inner diameter of the washer is cut with the help of this piercing punch, and then this tips moves forward, and then this guide pin goes into the holes already cut at this station, and then this blanking punch cuts the outer diameter of the washer. So, first of all we get a hole like this, and then we get a washer like this. So, in this progressive die, at each with each stroke of the press we get a finished washer. Then comes a transfer die. Unlike progressive die, where the stock is fed progressively from one station to another station, in transfer dies the already cut blanks are fed mechanically from station to station. So, in progressive die the sheet is fed automatically from one station to another station, but in transfer die the blank which are cut at one station are transferred mechanically from one station to the another station. This is the only difference between transfer and progressive die. Then comes multiple dies. Multiple or gang dies produce two or more work pieces at each stroke of the press. A gang or number of simple dies and punches are ganged together to produce two or more parts at each stroke of the press. So, what we do here in this multiple dies, as the name suggests, multiple die or gang die mean more than one tool or more than one dies are used to produce more than one workpieces. Then comes drawing operation. Drawing operation is the press. Drawing operation is the press process of forming a flat piece of material into a hollow shape by means of a punch which causes the blank to flow into a die cavity. So, in case of drawing operation, what we do, we form a hollow shape from a flat shape. Now, this type of drawing may be of three types. One is shallow drawing, second is deep drawing, and third may be moderate drawing. In shallow drawing, when the depth of the cut, when the depth of the draw is less than half of the diameter of the formed cup, then this type of drawing is called shallow drawing. And when the depth of the draw is more than the diameter of the formed cup, then this type of drawing is called deep drawing. And when the depth of draw is in between the half of the diameter of the formed cup and the full diameter of the formed cup, then that type of drawing is called moderate drawing. So, we have three types of drawing: shallow drawing, moderate drawing, and deep drawing. Then comes bending operation. Bending is the metal working process by which a straight length is transferred into a curved length. During bending operation, the outer surface of the material is in tension and the inside surface is in compression. The strain in the bent material increases with the decreasing radius of curvature. The stretching of the bend causes the neutral axis of the section to move toward the inner surface. In most cases, the distance of the neutral axis from the inside of the bend is 0.3 t to 0.5 t, where t is the thickness of the part. Now, you can see on the monitor that a straight length has been transformed into a bent length,